point is to find solution of dual from to find solution of dual problem from the simplex table from the primer means to find the solution of primer problem by using dual problem by simplex method. Okay, finding the solution of primer problem by using dual problem by using method simplex method. Okay, so there are two conditions. First one is if the primer variables corresponds to slack starting variable in primer problem. If the corresponding to slack variable or starting variable in the dual problem its optimal solution or its optimal value is directly read from net evaluation of corresponding to slack variable Okay, so if the primer problem corresponding to slack variable starting variable, that is if primer problem means problem is maximum type and all constraints are less equal type, when slack variable when added in a given constraint, if the constraints are less equal type. Okay, if problem are given that maximized type, okay, then their first simplex table is must be slack variable. Okay, their first simplex table is must be slack in BC's column, Y.B. column, first simplex table take a slack variable, then its dual problem, its optimal solution is directly read from the net evaluation of corresponding to slack variable. Net evaluation means after solving by using simplex method dual problem, then lastly directly write the solution from the Zj minus Cj. Okay, so Zj minus Cj of given optimal solution. Their solution is also seen in examples directly. Okay, and then second is if primer variable correspond to artificial variable, means primer problem is given that minimized type and all constraints are greater equal type. Okay, artificial variable in its dual here slack variable in its dual problem its optimal solution or optimal value is directly read from net evaluation of corresponding to this corresponding to this artificial variable. Okay, so to see that examples, obtain the dual of following problem. Obtain the dual of following problem. Obtain the dual of following problem and solve the dual problem. Solve the dual problem by simplex method. Also find the solution of primer problem. Okay, so given LPP is given that, suppose that maximum Z. Okay, maximum Z is equal to 3W1 plus 5W2. 3W1 plus 5W2 subject to 3W1 plus 5W2 subject to here 3W subject to 2W1 plus 8W2. 2W1 plus 8W2 is greater equal 40. So here minimize type. Okay, all constants are greater equal type here given. So here minimum z is equal to 3W1 plus 5W2 subject to 2W1 plus 8W2 is greater equal 40, and 3W1 plus 4W2 is greater equal 50, and W1 and W2 are greater equal 0. Okay, so question is, firstly find the right dual of this primer problem. This is our primer problem. Objective function is minimal type, all constants are greater equal type, and non-negative condition also given. Okay, so this is our primer problem. Firstly write its dual, then first write its dual. After writing dual problem, then given dual problem write in standard form, means with adding artificial variable, slack variable, separating surplus variable. Okay, so then after writing standard form of LVP, then find the Zj minus Cj, that is we have to draw simplex table. Okay, so solution of this dual of given LPPs, here objective function is minimize type, so their dual is maximize Z. RHS of constants are 40x1 plus 50x2. Number of two constants are given and variable also 2. Okay, so here number of variable constants also 2 and variables also 2. Here variables are x1 and x2. In primer problem variable are w1 and w2. Okay, subject to 2x1 plus 3x2 is, here all constants are greater equal type. In its dual, constants are less equal type, and which is less equal to coefficient of 3 in objective function, coefficient of w1 in objective function. Then second is 8x1 plus 4x2 is less equal 5, and x1 and x2 are greater equal 0. Okay, this is our dual problem. To find the solution of this dual problem by using simplex method. So here all objective function is maximum type, and constants are also less equal type. So only adding two slack variable, because this is a less equal type, only slack variable is added. If these constants are greater equal type, then we have adding subtracting surplus variable and adding artificial variable. Okay, so here only adding slack variable. Okay, so standard form of above LPP is The standard form of above LPP is the standard form of above LPP is, this is dual problem, this is primal problem. Okay, so write this in its standard form, that is adding two slack variable and putting their cost in objective function is 0. Okay, so therefore maximum z is equal to 40x1 plus 50x2 plus 0s1 plus 0s2, then subject to 2x1 plus 3x2 plus s1 equal to 3 and 8x1 plus 4x2 plus s2 equal to 5, where x1 x2 and s1 are greater or equal 0. Okay, so using this LPP we have to find the zj minus cj. Okay, we have to find the zj minus cj. Now we have to calculate zj minus cj. Okay, now we have to calculate zj minus cj by using zj minus cj. Okay, so right column, we draw simplex table, first cb, then xb, sorry, then yb, then xb, x1, x2, and here only one variable is s1 and s2, only two slack variable. Okay, upper side cj means coefficient of objective function x1 x2. Okay, coefficient of x1 x2 in objective function, so this is 40, this is 50, then there 0 0 in basis variable. Firstly directly in first simplex table write a slack variable s1 and s2, their coefficient in objective function is 0, their cost is RHS of constraint, so write their coefficient 2 3 1 0, then 8 4 0 1. Okay, so find their zj minus cj. Okay, firstly draw zj. Okay, zj is a zj 0 0, because cb column is 0, therefore all entries are 0. Then zj minus cj is equal to 0 minus 40 minus 50, then 0 0. Okay, so this is most negative, this is our key column. Okay, then find ratio how to find xb divided by key column is our x2. Okay, that is 3 divided by 3 is 1, and then 5 divided by 4 is 1 point something. Okay, 1.25. Okay, 1.25, therefore this is the most negative, so this is our key row, this is key row, so intersection of key column and intersection of key row is element is, this is element 3, and 3 is our leading element, so converting leading element, here 3 is leading element, 3 is our leading element, convert leading element into unity, converting leading element into unity by dividing leading element itself, by dividing leading element itself. Okay, and making other elements, making all elements in its column, all elements in key column or in its column 0. Okay, so and lastly here introduce introduce x2 and remove s1 in yb. Okay, so therefore next simplex table is cb yb xb, then x1 x2 s1 and s2 0 0 50 40. In this column x2 their value is 50 0 s2 as it is. So dividing this row by 1 by 3 r1 1 by 3 r1 3 by 3 is 1 3 by 3 is 1 2 by 3 3 by 3 is 1, then 1 by 3, then 0. So next row next operation is r2 is old r2 minus 4 r1 is new r1 in this column. Okay, so 5 minus 4 is 1, then 8 minus 8 by 3 what is value? This is 8 minus 8 by 3. 24 minus 2 is 24 minus 22 by 3. Okay, 22 by 3 or what value here? This value correct or not? 8 minus 8 by 8 minus 8 by 3, 16 by 3, 16 by 3. Okay, 8 minus 24 minus 8 16 divided by 3. Okay, so 4 minus 4 is 0. Then here 0 minus 4 by 3 is minus 4 by 3, and then lastly here 1 minus something 1 minus 0 is 1. Okay, so here again find zg. So zg column 50 100 divided by 3. Okay, this is 100 divided by 3, then here 50, then here 50 by 3, and here 0. So zj minus cj 100 by 3 minus 40, 100 minus 120 minus 20 by 3. Here 50 minus 50 0, here 50 by 3, and here 0 as it is. Okay, so this is our key column. So then find ratio xb divided by x1. xb divided by x1 is 1 divided by 2 by 3 is equal to 3 by 2. Okay, is equal to 1.5. Then 3 by 16, 1 divided by 16 by 3 is equal to 3 by 16. This is 0 point something. Okay, so this is our key column is, this is leading element. Okay, this is our second row is key row our, and therefore intersection of key column and intersection of key row is this is our leading element 16 by 3. So multiply this by 3 upon 16 r2. Okay, make our above elements in 0. Okay, so directly in this write here cb yb xb, then x1 x2 s1 and s2 0 0 0 0, then 50 40. Okay, so and introducing x1 and leaving s2. Okay, introducing x1 and leaving s2, we get x2 x1 50 40, x1 x2 50 40. Okay, so then here second row multiplying by 3 by 16, we get 1 into 3 by 16, their value is 3 by 16. For second, 16 by 3 into 3 by 16 is 1, then 0, here minus 4 by 16 into 3 by 16, 3 get cancelled, remaining only minus 1 by 4. Okay, minus 1 by 4, and then s2 column is 3 by 16 as it is, 3 by 16. So operation here, take operation here, uh, operation here how to taking r1 is old r1 minus 2 by 3 r2 is new r2 is in next column. So r1 is 1 minus 3 by 16 into 2 by 3, 1 minus, here operation is for this column 1 minus 2 by 3 into 3 by 16, 3 get cancel, 1 by 8, 8 minus 2, sorry 8 minus 1, 7 upon 8, 7 by 8. Okay, so for second, 2 by 3 minus 2 by 3 is 0, then 1 minus something, 1 minus 0 is 0. Then for S1 column is 1 by 3, 1 by 3 minus 2 by 12, 1 by 3 plus 2 by 12, 1 by 3 plus 2 upon 3 means 2 by 12. So 4 plus 6 by 12 is 1 by 2. Okay, and then next is 0 minus 2 by 3, multiply this by 2 by 3, 3 get cancelled, remaining only 1 by 8. Okay, minus 1 by 8, 0 minus something. Okay, then find zj minus cj. Zj minus cj here 0, directly write 40 minus 40 0, then 50 minus 50 0, then 45. Okay, here sorry 25 minus 10, 25 minus 10 is 15. Then here minus 15 by 8 plus 120 by 16. So finding there minus 50 by 8 plus 40 upon 16. So multiplying here 200. Okay, 100 minus 60 by 16. Okay, minus 16 by 60, or here how to multiply here, finding minus 50 by 8, then multiplying this by 16, 100 minus 60. So their value, what is their value? If we multiplying this by 4, then 4 15. Okay, minus 15 by this, here 120, sorry this is 120, 40 into 3 120 upon 16. So 20 by 16 is 5 by 4. Okay, so this value is 5 by 4. How to find in this? Minus 50 upon 8 plus 120 upon 16. So multiply this by 2, then this is 100, minus 100 plus 120 is 20 divided by 16. 20 divided by 16 is 4 and 5. If we dividing 4 to both elements, then 5 by 4, minus 0, 5 by 4. So all zj minus cj are greater or equal 0, and therefore maximum z is summation of cbxb column, summation of cbxb. So this is 50 into 7 upon 8 plus 40 into 3 by 16. Then their value, what is their value? 8 plus 120 divided by 16. So multiplying this at 820 divided by 16, 820 divided by 16. So if we dividing 4 by 2 both elements, then here 4, here 4 5. Okay, sorry 205 205. This is value is 205 divided by 4. Therefore maximum Z is equal to 205 divided by 4 at what value? X1 is equal to 3 by 16 and X2 is equal to 7 by 8. Okay, so this is a solution of dual problem. This is solution of dual problem, and therefore this is solution of dual problem, and therefore now in net evaluation the solution of primal problem, net evaluation, the value of slack variable, the value of slack variables S1 and S2. This is solution of dual problem, because here we have to finding the solution of dual problem. This is our dual problem. Okay, so we have to find the solution of primal problem. So how to find the solution of primal problem? Primal problem is minimized type problem. Okay, so their solution by using net evaluation. Okay, so here given that if the primal problem corresponding to a slack variable starting variable, in the dual problem its optimal solution is directly read from the net evaluation of corresponding to slack variable. We have to find the value of slack variable in its dual problem. Okay, so here now in net evaluation the value of slack variable S1 and S2, value of slack variable S1 and S2 is 50 into 1 by 2. S1 and S2, value of S1 and S2 is summation of CB into S1 for S1 column 50 into 1 by 2 plus 40 into minus 1 by 4. This is value of S1, and for S2 column is minus 50 divided by 8 plus 120 divided by 16. So their values are 15 and 5 by 4. 15 and 5 by 4 with S1 and S2 are values of S1 and S2 are 15 and 5 by 4 with maximum Z is 205. So minimum Z is equal to is also this is a minimum Z. Okay, so minimum Z is equal to 205 divided by 4. 205 divided by 4. Therefore minimum Z is equal to 205 divided by 4 at W1, taking value W1, because in given example coefficients are W1 and W2. Okay, so variables are W1 and W2. W1 is equal to 15 and W2 is equal to 5 by 4. Okay, so 5 by 4. If we taking W1 and W2, values of W1 and W2, okay, 3 into W1 45 plus 5 into 25 by 4, 3W1 plus 5W2. If we taking 15, 45 plus 25 by 4, here 90 180 divided by 4 plus 25 by 4, this is 205 by 4. Okay, so this is our solution of given problem. Okay, in this way find the solution of given problem. If here in this column firstly if given that primer problem is maximized type, then its dual is minimized type. Okay, then its dual is must be minimized type. Then we in first basic column, so we have to only taking artificial variable. Okay, a1 a2 up to so on. So taking artificial variable and find the any one method of big M method or phase 2 method. Okay, using find the solution of by big M method or a simplex method, whatever may be. Okay, so after finding their solution, lastly directly write the net evaluation of artificial variable. Okay, suppose that here two columns artificial variable a1 and a2, then take the directly value. Here already we have to finding their value. Okay, 15 and 5 or in this way we are directly finding their value. So this is their solution. So only take the w1 s1 and s2 net evaluation of artificial variable a1, artificial variable a1 a2 whatever may be. Okay, put their values in its solution for primer problem. Okay, in this way